Good morning. We are now starting our unit on probability. So before we get into actually calculating some probabilities, you probably need to know some vocabulary words. So there are two types of events that can occur. There's a simple event or a compound event. A simple event is when one event is happening. For example, I'm rolling a 1 on a die. I'm rolling a 2 on a die. A compound event is when there are two events that can happen at the same exact time. For example, this happens a lot when we are drawing cards from a deck of cards. I can draw a black card and also draw the ace at the same time because there are two aces that are black cards. See what I mean? Alright, so now you know some of the two vocab words, but we also need to add in mutually exclusive. Mutually exclusive events are events that have at least two events that cannot occur at the same time. Okay? So two events that cannot occur at the same time. For example, being a boy and a girl. I know that's a little bit controversial right now, but let's dive in. What is the probability of drawing a 2 or an ace from a standard deck of cards? This again is one of our examples of a mutually exclusive event because there's not a card in a deck of cards that is both a 2 and an ace. See what I mean? I'd also like to highlight the word or. The word or in probability means add, okay? So what we're really doing here is we're doing the probability of a 2 or an ace, which is really equal to finding the probability of drawing a 2 plus the probability of drawing an ace. So the formula that I just wrote out for you is actually the sum of probabilities formula, where we have the two events, either or is happening, and you're adding them together. Some background knowledge that you need to know. There are 52 cards in a deck of cards. Well, how many 2s are there in a deck of cards? There are 4 out of 52. The 4 in the numerator always represents the number of cases of that specific instance. So in this situation, the number of possibilities of drawing a 2. We got the 2 of spades, the 2 of diamonds, the 2 of hearts, the 2 of clubs. Out of a total of 52 cards. Now we look to the aces. And we're adding them because it's an or. The probability of drawing an ace is actually the same as the probability of drawing a 2. There are 4 aces out of the 52 cards in the deck of cards. When we add our fractions together, they both have a common denominator, so that makes my life pretty easy. So we have 8 out of 52. But we know that this can be simplified. A number that goes into both of these terms is the number 4. So this simplifies to being 2/13. So the probability of drawing a 2 or an ace is 2/13. All right, so let's get into a little bit more of a tricky mutually exclusive event happening. So the question reads that there are 7 girls and 6 boys on the junior class prom committee. So I'm going to start to actually write down my information. That's actually a good action to do when you're solving these problems. So we have a total of 7 girls, and we have 6 boys. Okay, it's a little hard to read because I grabbed the wrong marker. A subcommittee of 4 people is being chosen. So there's that 6 boys. But the subcommittee is only going to hold 4 people total. Okay. So they're decided at random to choose the theme for the class float. What is the probability that the subcommittee will have at least 2 girls? So this means at least 2 girls. What that could mean is we could have a choice of having 2 girls being chosen for the 4. We could also have the probability of 3 girls being chosen for the 4. And we can also have the probability of 4 girls being chosen for that prom committee. So I'm going to set this up. We could have 2 girls. Once again, I'm adding these probabilities because 2 girls and having 3 girls cannot happen at the same time. And I'm also adding the probability of 4 girls. So something actually is also happening during these events. This is why this is actually going to be a compound event. When there are 2 girls on the subcommittee, there also have to be 2 boys. remember, they're going to add up to 4 total people. When there are 3 girls, there is 1 boy added onto the subcommittee. And when there are 4 girls, there are no boys on the subcommittee. So I just want to set that aside because it's going to be information that I need to know. Now, anytime there are people, shoes, necklaces in the probability, we actually don't know the number of ways that these people can be chosen. Yes, we're recognizing that Bob, Joe, and Leanne are the same as Leanne, Joe, and Bob. However, we don't know out of these total number of people how many different ways I can choose these people. And notice I said the word choose. Choose means combination. So we actually have to calculate the total number of combinations for each of these probabilities. Remember, the total goes on the bottom, the total number of arrangements. In total, there are 7 girls and 6 boys. So in total, there are going to be 13 people chosen. Well, 13 people you can choose from. And you're only going to choose 4 of them. So on the bottom, our total number of combinations for our total is 13, choose 4. Now on the top part, remember we're having 2 girls. So we're having out of 6 girls, we're choosing only 2 of them. But we're also, oops, I'm sorry, there's 7 girls, not 6. There's 7 girls choosing 2 of them. And at the same time, notice I said and at the same time, and means I'm going to have to multiply the number of combinations. Or I'm also doing 6 choose 2, representing the number of boys. At the same time, I have 2 boys and 2 girls. And means multiply. Now I still have the other 2 probabilities to deal with, but both of them are going to have the same denominator of 13 choose 4. Because I have not changed the total number of kids in the group, I have not changed the number of people being chosen. Over here, we have 7 girls to choose from, and we're only choosing 3 of them. And at the same time, remember, and means multiply, and at the same time, there's going to be 6 chosen 1 boy. So out of the 6 boys, I'm choosing only 1 of them. And then in the last probability, I have 7 girls to choose from, and I'm choosing 4 of them. And at the same time, out of my 6 boys, I'm not choosing any of them. So as you can see, this is actually a really big, long combination problem. You actually have to do a lot of calculations. So let's fast forward a little bit. Let's pretend I was playing on my calculator. I typed it all in. We figured out this first probability is 315 over 715. The second probability is 210 over 715. This last probability is 35 over 715. And when you add them all up together and you simplify, you get 112 out of 143. Wow. So remember, this was a question where it was an at least. What was the probability of getting at least 2 girls chosen? And at least means I can also have more than this situation. I can have 2 girls and 2 boys, 3 girls and 1 boy, or 4 girls and no boys. So actually, you have compound events happening within simple events, within mutually exclusive events, but there are 3 mutually exclusive events happening.